there, we're at the top of 103, continuing to talk about sequences and functions. We've got an example here that's asking us to do a couple things, and this is really a typical kind of problem when you're dealing with an arithmetic sequence. Remembering an arithmetic sequence gets from one value of a term to the next one, to the next one, to the next one by either adding or subtracting a constant value. So it's asking us to construct a table of values. We've got this pattern, these numbers in our sequence. So if you're looking at the first term, let's go and look at the zeroth term. So if this is the first term and this is the second term, that's plus 3, and that's plus 3, and that's plus 3. Well, notice we've left a spot in this chart for the zeroth term. And if we're adding 3 to get to each individual term going forward, it would make sense that if we subtracted 3, we were back at the zeroth term. So if we subtract 3 from 5, we're starting out at 2. So when we the zeroth term, which sounds kind of silly, the pattern is 2. So a sub 0, the value of the term when it's the zeroth term, is 2. The first term is this guy right here. So a sub 1 is 5. And what did we do to get that? We added 3 to the zeroth term. The second term is 8. So to the zeroth term, we added 2 3s. So a sub 2, the value at a sub 2 is 8. The value at a sub 3 is 11. And these you can just see off of the table, but I'm trying to expand the pattern here so that you can see what the pattern actually is. So we started at the zeroth term, we added the first term, the value at the second term, and the value at the third term to get 11. And then it would stand to reason that the next one we're adding 4 3s. So the value at the fourth term, a of 4, is 14. So we constructed the table of values. And now they're asking us to actually find what would the 40th term be. So if you filled in this chart, good luck, take y'all weekend, what would your value when a of 40 is? Well, we have a formula, we have a rule to find the value at any given term. So this is kind of cool, and this is what we're going to use going forward to find the actual value of any specific term. I don't care how big it is. So let's look at it. This is the general rule. And the general rule can actually be written 2 different ways. And different math books, some math books write it one way and some math books write it the other way. So at a of 1, the first term, and the common difference, so if you know the common difference and you know what the value is at the first term, then the rule says that the value at the nth term is equal to the value at the very first term plus n minus 1 times the common difference. So the common difference up here in our example, let's go back up here and write some stuff. So we know that the constant change is 3. Positive 3. You're adding 3 to get to each one of these. So that's our D. Our D is 3, the constant change. We talked about going backwards to the zeroth term. And if we look at this function rule right here, if I actually wrote the rule, write the function rule. I think I skipped down too soon. I should have done this first. But you guys can bear with me. The function rule for our pattern up here is a sub n. So I don't care what term you are adding 2 plus 3 times whatever term you're in. So if you look at the pattern here, to get to the value of the third term, we started at 2 and we added three, three threes. So 3 times 3 plus 2 is 11. Here we had 3 times 4 because we're talking the fourth term. 3 times 4 plus 2 gave us 14. So this is our function rule. 3 is the common difference. So if we want to skip way down to the 40th term, right here, we can plug it in our function rule. So we have a rule that says 2 plus 3n, but I know I want n to be 40. I want to know what is the value. This is the value when you get to the 40th entry in this string of numbers. So we can do 2 plus 120, and we get a of 40 equals 122. So now we can go back down here to this overall general rule that says, I don't care what your pattern is, I've got a general rule for you where you can find the value of the nth term, any term you want, if you know the value at the first term, and you know the common difference. So in our rule up here, let's see if we can do this. Our rule up here, a of 40 equals the first a of 1, so the first one was 5, plus, and we want 40 minus 1. This is, the n is 40. 40 minus 1, which is 39, and the common difference is a positive 3. So if this works out right, let's see what 39 times 3 is. 7, carrier 2. 4 times 3 is 9, so 11. So this is 5 plus 117 equals 122. So this rule, we just proved our answer up here, and we didn't have to know this pattern. We didn't even have to come up with the pattern. All we had to do was identify the value in the first term and know where we wanted to go to the 40th term. I told you that this is written in two ways. You see it in math books different ways. The second way that you might see it is when you don't know maybe the first term, but maybe you know the 0th term, which we've talked about a little bit. If you're doing it this way, then it's not n minus 1, it's just n. What term are you looking for, and what's the common difference? These two say exactly the same thing. I just wanted you to be aware that some math books use one and some math books use the other. So let's look at an example. Here's the sequence right here, 10, 6, 2, negative 2, yada, yada, yada. So it's pretty obvious, I'm sure, for you guys to see we're going down by 4 each time, minus 4. So our D is minus 4. That's our constant change, and it's negative. So the function rule, if we want to use, we can use either one, or we could try both. But if we use the function rule, well, we'll use the function rule for part B. Let's write a function rule. We need a pattern. We need to set up a pattern. So the function rule is, we're starting, and where would we be starting? What would be our 0th term? So we're subtracting 4 each time. So what does this 0 term have to be to get to 10 when you subtract 4? And so that's 14. 14 minus 4 is 10. 10 minus 4 is 6. 6 minus 4 is 2. 2 minus 4 is minus 2. So our function rule is at the 0th term, we started at 14, and we are adding negative 4 times n. For every term that we move, first, second, third, fourth, fifth, we are taking away 4. So a sub n is equal to 14 minus 4n. So we've done exactly what we did in this example up here. In this example, we figured out what the function rule was, what is the rule, and then we found the 40th term. Down here, we figured out what the function rule is, and now they're asking us for the 50th term of the sequence. So let's plug in. That's what we're looking for. A sub 50. Where is A 50? and we are going to use 14 minus 4 times 50. We are plugging it in the function rule. So a sub 50 is equal to 14 minus 200, and a sub 50 is equal to negative 186. Let me show you what it looks like when you skip writing the function rule yourself and you go use this formula up here. So let's use the first term one, this first one. So a sub 50, we want the 50th one. We have to fill in the value at a sub 1. So we look at the pattern. The very first guy is 10. All right, there he is. Plus n minus 1. So let me write the rule up here. So a sub n is equal to a sub 1, a of 1, plus n minus 1 times d. So the value of the very first term is 10. N minus 1, this is what we're looking for. We're looking for the 50th term. So n minus 1 is 49, and the common difference here is negative 4, and this is multiplied. So 49 times negative 4 is going to be our value if we were to string this pattern out to the 50th place, which I don't want to do that by hand. So I'm going to do it with the formula. Kind of cool. So this is 10 minus 196, which is minus 186. So this is exactly the same answer we got, but we got there quicker because we used this general rule and we didn't have to come up with the pattern itself. So we didn't need to know this other than the fact that the problem asked us to set it up. In order to use this rule, all you need to know is the value of the first term or the 0th term, and you need to know your common difference. Okay, thanks for watching.